Hello, this video is made for probability and stochastic processing class, homework 1, question 1 in homework 5. We look at question 1 is that we need to use convolution method to deal with this problem. So we need to use Laplace transform to transform the distribution function, density function of x and density function of y. Density function of x is unit function of x minus 1 minus unit function of x minus 2. And this is the density function of y. And we use Laplace transform of those to the two equation, and the answer is this. And we use convolution method, so we just times these two. Okay, times these two, and we get the answer. So now I look at the Laplace transform table, and I know that. So we need to use inverse Laplace transform, and we check the answer of the Laplace transform table. So I get distribution function, a density function of z is equals to unit z minus 1 minus unit 2 times unit z minus 2 and unit z minus 3. I'm sorry, it's plus. Yeah, it's plus. And the inverse Laplace transform of 1 divided by 2 is this. Okay. Actually, I don't need to write the unit function of z, because I write it before the right here. Okay. So that's the answer. Then we look at question 2. We need to use geometric method. So that we firstly need to calculate the distribution function of z. Then we take the derivative and we get the answer of density function of z. So we rewrite z by x plus y. So now I think I can draw the graph. We know that the density function of x is right here. So x 1, 2, x is x is above 1 less than 2, and y is 0 from 1. Okay, 0 from 1, x, y, here. This area is meaningful, and out of this area is 0. Now we draw a line across this area, and this line is x plus y equals to z. We know that we know that x plus y is less than or equal to 0 z. So this shadow area is under this line. So there are two different graphs. The first is this. The second is that the line is right here. The two graph is different because this line is not the point is not the point that on the x-axis is below than 2, and this graph is above than 2, and these two graphs we calculate them in a different way. I can just give an example of the first one. We take double integral. The x is from 1 to x, y equal to z. Okay. And y is z minus x f dx dy. Sorry, dy dx. Yeah, that's the way we get the distribution function of z, and then we get density function of z. We just take a derivative of this. Yeah, and we can use the same method on this graph, and of course finally we get the answer as same as question 1. And thank you very much.